right, I'm going to talk to you about the part 2 of last night's homework, chapter 6 homework, and we're going to kind of do those together as a learning component, and then I think with that being done that way, we'll be able to zip through some of the notes, and actually some of the notes are going to kind of become your assignment tonight for homework. So let's do that. All right, so move on down to number 12. Number 12 says, find the proportion of observations, that's that area or that's probability, between this number 176 and 185. The mean is 174, standard deviation 21.5. Well, could you go to your z-chart, or if you put on your calculator norm CDF from 176 to 185, then if you go to your z-chart, you're going to find that those high z-scores like that are not on there, because remember that a normal curve goes from -3 to +3 on the for the z values. Okay, so this 176 and 185 are not z-scores. You have to turn those into z-scores, and so the way that you're going to do that is do your z-score formula. X minus the mean over the standard deviation. X minus the mean over the standard deviation. So that's what I want you to do right now. Use your calculator. Take a moment and calculate the z-score for those two sections. The first one would be, this is your x value for the first problem. So it's going to be 176 minus the mean of 174 over the standard deviation of 21.5, and that gives you a z-score of 0.093. All right, then the next one, the z-score is going to be, here is your second x value, 185 minus the mean over the standard deviation, and that z-score is 0.5116. Now those are z-scores. Those are not areas. If I want to go then find the area or the proportion of observations, then I need to go to my z-chart and find the areas associated with those two z-scores, or as you just learned on the previous video, you could do your norm CDF from your low z, 0.093, up to the high z of 0.5116. Those are your two z-scores, and that will give you the area. And so if you try that, you'll find out that you get an area of 0.1584. All right, so take a few moments, see if you can't try number 13, and go ahead and do number 14 on your own. Take a few minutes, try number 13 and 14 right now. You don't have to draw the picture, just go ahead and calculate your z-scores and see if you can use your calculator to compute. So I did mine here in blue. I subtracted, I found my lower z-score to be -3.6, negative 0.3692. I guess I usually go to 3 or 4 decimal places on that. Actually, later, I kind of just end up going to 2 decimal places. So if you just rounded yours to negative 0.37, then that's going to change your answers to be slightly different from mine. But for the most part, it'll be about the same. The second z-score, when I subtracted, was 0.1538. So those are my two z-scores. So now I want to find that area between the low z and the high z. So I'm going to norm CDF from low z to high z. And so when I norm CDF from low z to high z, I get an area of 0.2051. So of course you could say 20.51%. And again, if you had rounded these, then you're going to get a slight bit different value. That's why it's important for me to see your work, because when I see your work and I see that you rounded to something a little bit differently than I did, and I see your numbers are slightly different in your area, then I know you still did it right. Okay, how about this number 14? Find the proportion of observations above 650. So you're going to want to find that z-score for that, and then go from that z-score above, so out to positive infinity. So try that now. Okay, so for that number 14, I got a z-score of 1.5. And then I norm CDF'd from 1.5 out to positive infinity, which I simulated as 99 standard deviations out. I got 0.0668, so 6.68%. And hopefully we all got that since it was just 1.5 for that standard deviation. All right. So let's now take a look at how 15 through 18 are different. So 15 through 18 start asking us for something other than the z-score or the area. They ask, number 15 and 16 ask us to find a particular mean. 17 and 18 ask us to find a particular standard deviation. So what you're going to find that you need to do on these problems is you're going to be given 3 out of 4 of these items that are in the z-score formula. You know, you got your z equals x minus the mean over the standard deviation, x minus the mean over the standard deviation. And you will be given 3 out of those 4 items. So let's see what we're given on number 15. Find the mean, so that means the mu is a mystery, of the distribution if the number 75, so what do you think that is? So I think that is certainly not a z-score. That's going to be our x value because it's our number. 75 is 1.6 standard deviations. So what represents the number of standard deviations? That is your z-score. Okay, so z is 1.6. Now it does say above the mean, so it is positive 1.6. So you do have to watch out for that and pay attention there. For example, number 16 is 2.5 standard deviations below the mean. So that z-score will be negative. All right, and it says the standard deviation being used is 12. So sigma is 12. So I'm going to fill in my little z-score formula with 3 out of 4 items, and I will then mathematically solve for the 4th. And I'm going to leave that part out. But you know that you would then substitute in, we would say 1.6 is the z, and that equals x, which is 75, minus mu, the unknown mean, over the standard deviation of 12. And I'm going to leave the algebra for you there to solve for mu. So try real quickly to list out, let's see if you can list out what your formula looks like on number 16. Let's see if you get all those values placed correctly. So try that now on number 16. So I hope that, again, you noticed your z-score is negative 2.5. because it is 2.5 standard deviations below the mean. So negative 2.5 equals x, which is 26.5, minus mu, you don't know, over the standard deviation of 6.7, and you're going to solve that. By the way, if you wanted to check your math and see what your values should come out to be, check your math. The mean for number 15, the answer is supposed to be 55.8. And the mean for problem number 16, if you solve it out correctly and do the correct algebra, the mean should be 43.25. Okay, so you could try those. All right. Number 17 and 18 are the same, except for the unknown is going to be sigma. And, of course, your x is your value, your 2.5 is your z-score, and it gives you the mean. In this case, number 17 gives you a mean of 35. So that's your mu. So let me give you a moment to try that one. This one typically is more difficult algebraically. So I'm going to go ahead and let you fill this in, and I'll show you this one algebraically how you handle that. All right, so here, algebra-wise, what are you going to want to do? I don't like having this unknown symbol on the bottom, so I'm going to multiply, of course, by my standard deviations on both sides. So I get that 2.5 standard deviations equals 50 minus 35, which is 15, and then I'll do my divide by 2.5, and that's how I get my sigma, is that value that I'm going for of 6. All right, and 18 will be the same way. So now that I've kind of walked you through that, looking at these notes part 3, these should end up being pretty quickly now that we've done the calculator part and we've kind of looked at some problems with that. These should go pretty quickly. So let's go through some of these. Number 1, find the z-score for the lowest 10%. So inverse norm of the area below is the z at that spot. So you can just show your, you can just write down the calculator speak for right now. On the AP exam, do be aware that just writing down calculator speak is not acceptable in all situations. You need a z-score formula in a lot of things. So inverse norm that area below. So I'll let you try that. Put that in your calculator, see what you get. All right, and let's just go ahead and do these z-scores to 2 decimal places. I'm going to try and start fixing my keys so that they are that way. It makes it easier on everybody. Okay, find the z-score for the highest 5%. That means that I have the lowest, what? Because it has to be inverse norm of the area below is the z at that spot. The lowest, 95%. So I'm going to inverse norm the bottom 9.95. So that's what I'm going to put into my calculator, inverse norm 0.95, and I'm going to get 1.65. All right, now find the z-score for the middle 50%. So if I've got the middle 50%, I want you to think of how that's going to look. If I have this is middle 50%, then I have got the 50% in the middle, which makes this z-score here is above how much? So that lowest area is 0.25. Almost kind of makes me think of the box plot situation. And here is the middle 50%. So if this is the middle 50%, then this z-score here is going to have how much below it? It's going to have that 0.25 plus the 0.5. So our first, we have 2 z-scores on this. We'll have inverse norm of the bottom 25%. That'll end up actually giving us the value of Q1, which we'll talk about tomorrow. And then the top one will give us the Q3, which is going to be the inverse norm of the bottom 75%. So you find those 2 values, and those would be your negative 0.67 and your positive 0.67. And do you think it's strange that they are the same value, but one is the negative and one is the positive? And that should be not surprising. Because of symmetry, you are equidistant away from the mean, so therefore you're the same amount of standard deviations away from the mean. Okay, so then for your homework, you're going to do these 3 problems here. Okay, let's move on because I want to do a couple of these 2 fill-in-the-blank problems, and then I'll see if there's any other homework I want you to do. All right, so here we have this application problem. A pizza parlor franchise specifies that the average amount of cheese on a large pizza should be 8 ounces. So we're going to start listing all of our information over here to the side, and a standard deviation of just 0.5 ounces. An inspector picks out a large pizza at random in one of the pizza parlors and finds that it is made with 6.9 ounces of cheese. That is our X value, 6.9. Okay, so if the pizza parlor is really putting 8 ounces of cheese on the pizza, what's the probability that the randomly chosen inspector chooses 6.9 ounces or less? So we're going to then find our z-score. So we're going to typically, on a word problem, make ourselves a menu over here on the left side of all of our information. So this z-score is going to be my x minus the mean over the standard deviation. So my 6.9 minus the 8 over the standard deviation is negative 2.2. And so now I want to, it says find the probability. So I got the probability that I get a z-score less than negative 2.2. So how are you going to do that? If you're thinking of a picture, you're way down here at negative 2.2. And you want to find this area. So you can get that from your z-chart, or I'll tell you how to get that on your calculator. You could norm CDF from negative infinity, which is negative 99, up to negative 2.2. Okay, so if you find that, then that gives you the 0.0139. So 1.39% chance of finding a pizza with that little cheese on it if they really are putting 8 ounces of cheese on the large pizza. Okay, and this next one says if the amount of cheese on the pizza is 3 standard deviations below the mean, then the pizza parlor will be in danger of losing its franchise. What's the minimum amount of cheese that needs to be on that pizza? Okay, well, let's write the things we know. The mean is 8. Standard deviation is 0.5. X is what we don't know. That's what we're trying to figure out, how much minimum cheese, so that, okay, if it's below 3 standard deviations, so I need to figure out, that is the z-score. 3 standard deviations below the mean, so that z-score then is negative 3. So set yourself up your z-score formula. That z is x minus the mean over the standard deviation, and fill in your information to solve for that cheese amount. And so then what I find is that x equals 6.5 ounces. So if somebody comes in there and randomly picks out a slice of, or a pizza, and it has less than 6.5 ounces, well, that is the minimum. Okay, that's the minimum. If it has less than that, then they are in danger of losing their franchise because they are not up to standards. All right, I think then that what I want to do is, besides having you do those few problems up there for homework. Okay, and so then we're going to skip on down to number 11. This one you are finding those z-scores. So I'm having you do for homework the problem numbers 4, 5, and 6, and this number 11. Now let's take a look at this number 12. This one, I want to talk to you about this notation here using N is 1152 and 84. And so it tells you which means the normal model with a mean of 1,152 and a standard deviation of 84. So find the values at what percent of steers weigh over 1,250, under 1,200, and between those two amounts. So of course what you need to do is find their z-scores first, and then you can do your norm CDF on your calculator. Here, you're going to have the same situation, and it says the highest 10% of weights. So you first use this information to find your z-score, and you have your mean and your standard deviation, and so you're going to be finding the x values on those, okay? Whereas up here, you get your z-score and then norm CDF to get the areas. Okay, so those are 2 steps. And then finally, number 14, they give you lots of different information. Here, this gave you the mean. This says 35% below 1200. 1200 would be your x. 35% below is going to be information to get you a z-score. Is going to be your inverse norm of the area below of 0.35, and that will get you your z-score. So see, what you're doing is you're identifying all the different pieces. You have your mean, 12% is the higher part above. This is your x value, and so on. So you're going to find whatever is missing. In this case, A is looking for standard deviation, B is looking for standard deviation, C is looking for mean, and D is looking for the mean. All right, so in summary, your homework is whatever pages those are. I think pages 15 through 18 or 16 through 18. You were doing those numbers 4, 5, 6. And then you were doing these problem numbers 11 through 14 to finish that out. All right, and you should use your calculator. Hopefully you have one at home for that.